Hello everybody, today I want to talk about some key parts of a quadratic function. A quadratic function is a function where, one that you are familiar with is the form of ax squared plus bx plus c. And in this part of the chapter, we're going to extend that and put it as y equals. Sometimes that y is represented as f of x. So you can also see this as f of x equals ax squared plus bx plus c. You can think of the word function as equation if that is more familiar to you, but we will be using the word function throughout this chapter. All right, let's begin with the way that the graph looks. The graph of a quadratic is a curved shape, okay, that we call a parabola. And again, that's pronounced parabola. A parabola is, if you were to think of its shape, is a U-shaped graph. Okay, there are two ways that a parabola can look. A parabola can face up. A parabola can face down. There are ways that we can tell from an equation whether a parabola is going to face up or down, and we will be talking about that as the unit goes on. So let's talk about some key parts of this quadratic graph known as the parabola. One of the key parts of a quadratic graph is what we call the vertex. A vertex is the center or middle point of the graph. Remember that a point on a graph is always written as the ordered pair x, y. So we can think of the vertex as either the highest or the lowest point on the graph or of the graph. Often instead of highest or lowest, they like to use the term maximum and minimum. Okay? So if you're looking at a picture of a parabola, if the parabola faces down, your vertex is going to be that center, most highest maximum point, right there. If your parabola faces up like this, your vertex is going to be the lowest or the minimum point of the graph. Okay? A vertex is something that whenever you graph a parabola, you must have it as part of your graph. So this must be part of your graph. Okay? All right, let's move on to the next key part of the graph. The next key part of the graph is what we call the axis of symmetry. So the axis of symmetry is a vertical line that goes through the vertex And often on a graph, it's represented using a dashed line. Okay, the axis of symmetry, if we're looking at a parabola and you have a vertex, it'll look something like this. Think of the axis of symmetry sort of like a mirror. If you were to fold your parabola in half, where the axis of symmetry was your fold, each side of the parabola would line up with each other perfectly. It cuts the parabola into two symmetric sides, meaning that a point over here will be the same distance away from a point over here, this is something that we will definitely talk more about. Now, since the axis of symmetry is a vertical line graphs are always written as an equation, where it's x equals some number value. Okay? Since it is a line, when we represent the axis of symmetry, we represent it as an equation. So this is what an axis of symmetry name will look like. This value here, you will see, ends up always being the x value of this number here always ends up being the x value of the vertex. Okay, so, and as we go through this unit, we will talk more and more about these things, so you will become more and more familiar with them. For right now, this is just vocabulary. So let's talk about other key parts of a quadratic graph, and those are what we call the intercepts. In a quadratic graph, you can have both X-intercepts and you can have a Y-intercept. Okay, remember from linear equations what these two things are. For an X-intercept, it can have 0, 1, or 2 X-intercepts. Remember, an X-intercept is where the graph crosses or touches or intersects the x-axis. Any point on the x-axis will always have the form of some x value, comma, 0. For a x-intercept, the y value is always 0. Now for a y-intercept, a quadratic, we'll have one y-intercept. It cannot have 2 because there's no way for it to loop back around and hit the y-axis again. For a quadratic function, remember that a y-intercept is where the graph crosses, touches, what intersects. There's lots of different words you can use. It's where the graph crosses the y-axis. Okay, so for a quadratic, or any type of function, a point that is on the y-axis is always going to be 0, comma, y, where the x value is always 0. Now, to just relate that to the form that I wrote up above, the y equals ax squared plus bx plus c, imagine if you plugged in 0 or evaluated the function when x is 0. Well, 0 times anything is going to cancel that out. 0 times anything here is going to cancel that out. So whenever it's in this form, you can see that it's going to be fairly simple to see, no pun intended, that the y-intercept is going to be this value here whenever you evaluate the function when x equals 0. So later you will see the connection that the y-intercept can also be thought of as the point 0, c, where c is that constant value in standard form. Okay, so let's take a look at all of this stuff together. Okay, so we're going to look at this example here. So in this example, we have a picture of a graph. This is a quadratic graph. You can see that the shape of it is a parabola. And all the key parts of this graph are labeled here. Or they're noted with an arrow, I should say. We're going to label them. So one of the first key points of the graph is the vertex. And in this instance, or this problem, the vertex is the point 1, -4. And moving on to another key point of the graph, or a key part of the graph, would be what we call the axis of symmetry. So the axis of symmetry, remember, that is a line. So when we write where the location of the axis of symmetry is, we write it as an equation of a line. It'll always be written as x equals, and in this case it's 1. So this number 1, you'll see, is also the same as the x value of the vertex, because the axis of symmetry will always go through the vertex. Another key point of the graph is the point that lies on the y-axis, which we call the y-intercept. The y-intercept is the point, in this case, it's the point 0, -3. Remember, with the y-intercept, the x value is always 0. These red points here, those are the key points that we call the X-intercepts. It is possible to have more than one X-intercept. In this picture, there are 2 of them. They are the points -1, 0, and the points 3, 0. Remember, with an X-intercept, the y value is always 0. So you will definitely get more practice with this type of problem. So I hope that you like this video, and best of luck with your practice on this.